Hi folks, today what I want to take a look at is Whitebox learning gliders. So I'm just going to go over some of the basics and hopefully this will help you get started. So first of all, you can get there through Classroom, go to gliders, here's our link, and just a reminder, go into view assignment to find your login information. So I'm going to go ahead and log in, we're going into gliders, so I'm going to go ahead and log in with my student ID and my group ID. If you're in my class, it's anyone in my class is going to be 1131. If you're in Mrs. Craig's class or someone else's class, it's going to be different. And whatever your individual student ID is, and we'll do login. Also, we found a new way to log in through Google, so it's highly possible here in the future that you can just go in and click login with Google, which the first time you need to log in this way, and then there's a button you can click to allow it to log in with Google, and then from there on out you can click on login with Google. But since we just found it, we'll really probably roll that out next semester. So first of all, if you're just coming in and just starting, we actually want to start at start, which goes to research. So I'm going to click that. Now you can click on the little tabs down the side here, but please don't, and here's why. Use the next and previous buttons. First part is going to cover engineering design process, which is immensely important to us down here in the tech world. The design challenge, this is going to explain what the challenge is and all of the different requirements. When I use next, here's why you want to use next and previous, is we're going to get little tutorials to pop up, and if it ever does this, I can go to next and go back to previous, and here sometimes it's just a little hiccup in the internet. But so tutorials, always have issues with tutorials. Tutorials are meant to walk you through doing something, so don't just read it. When you get through here and it gets down and says for you to select the engineering tab, actually do that. Don't just read it and keep going. Like, actually do what it tells you to when it tells you to do it, and then we can work from there. And also, all of the reading stuff in here, if you mouse over it, there's a little headphone icon. Click it, and it will read this stuff to you. So, if you're use that if it benefits you. We'll leave it at that. I go into next and design tutorial. This is going to show you about how to actually make a plane, a glider. So all this stuff is so important. And I know there's a lot of reading and a lot of stuff to it, but it truly, truly, truly is important. And it goes right along with our engineering design process. And that's why I have you all using this program, is so you can really get a better understanding of this process. You can do it way better with something virtual than you can in our class with physical things, because here we can keep remaking designs and testing them and remaking them and testing them and adjusting, where we can't physically do that with, it's cost prohibitive, it's time prohibitive to do that with physical materials. So you want to read through this, and as you're going through forces of flight, and again, this is going to go right along with rockets when we do the rockets, or some of you now maybe have done the rockets, little quizzes that are built in. Now with the quizzes, take your time, do well for a couple reasons. One, we're going to put that in as a grade. Two, you're in game mode, which level 1 here, there's 5 total levels. When you click on this, it's not going to show you all this stuff unless you've went through all 5 levels. Then it shows up like this. But the other reason that these grades on these little quizzes, worksheets are so important is those points will follow you from level to level. So if I get 100 points on all my quizzes there, then that's going to follow me level to level, and that's that many less points I need to get to move up. So grades, I can get up to 100 points towards leveling up from my grades, and it goes level to level. Performance on each level, and it resets each time you level up. You can get up to 100 points for your performance, how well your glider does compared to whatever norm they've set. And the third one here is you can get up to 50 points for iterations. Now an iteration, what an iteration is when you've made your design, you've tested the thing, and you get your results. When you go back, make adjustments, save it, and retest it, that is an iteration. So every time that you go back, adjust it, save it, run it, it's going to give you points toward iteration. If you are in spec, which all that is covered right here in spec iterations, that's covered in the research. Do the research. Break it up over, a couple days, but do the research. That's how you'll know how to use the program. Weight, another quiz, lift quiz, drag, a few more, another tutorial. So another quiz, another tutorial, optimization, another printing templates. Unless you're in TSA, you're probably not going to need to worry about this, but um, we want to go through all these things. At that point, we would move into engineering. Here's where I'll spend a little more time, and hopefully this will help you out if you're confused with this. So, and of course, this is covering a few of the things that I really want to see, but so my fuselage, there's my fuselage, here's my wing, my horizontal stabilizer, and my vertical stabilizer. These are the default settings, and it just, this is how it comes up, and then you go in and you make your glider from this. This is the base model. This is not Google. It does not save itself. I like to do this right at the beginning. I'll go into File. I'll save this. I'll name it something. How about glider for video? Just name yours something school appropriate. Notes, each time you go in and save, you can add yourself notes, and it's really helpful. But just getting started. Save a working copy, only I can see it. It doesn't go out into the main internet where other people can race on here or fly against you. Save and enter competition will, so I'm going to do save a working copy for now. Now, let's see. You used to be able to move this from side to side. It doesn't look like I could do that, and this won't move, unfortunately, or I'd move that so you can see a little better, but here's exactly what I prefer to do. All these things are helpful. The weight, we got to have so much mass on the glider. Lift, I can get my numbers for lift and drag, and all these different things. I can go in and see my exact numbers, but for now, here's my personal preference, and could surely get you started out pretty well. I'm going to turn on the eyeball for optimization. The eyeball is going to show or hide things, is all. If I'm in red, I'm going to nosedive, and it's going to be a terrible design. I want to get all these little sliders here up as far as I can to the right within our specifications. So like weight is the one that I won't be able to get clear up because I'll be out of spec or out of our required limits. So let me just show you that real quick. In outputs here, outputs, design specifications, you will be back and forth between engineering, outputs, and competition quite a bit. And research. Just because you did the research once doesn't mean, that it's a lot and you're not just going to remember everything. Anything here in red is out of spec, or what we mean by that is it is not between the minimum and maximum specifications. That's what we're calling out of spec. It's either too little or too much. So the length is 302, it has to be no greater than 300. Span is 302, it has to be 300 or less. True length flattened out, same thing. So fuselage, wing inputs, horizontal stabilizer, vertical stabilizer, and our mass. Let me just point out that the glider has to weigh at least 5.5 grams. There's no maximum. go back to engineering. Because I need a good bit of mass, I'm not really going to mess with the fuselage right now. Totally play around with stuff. I do like to take some of this ballast off. And this is an arbitrary number. It doesn't really mean anything. I'm just putting a number in that's less. Apply so it actually happens. That's going to take my mass down, which is moving this weight up, but I can always come in and change any of this at any point. Oh, in fuselage, I was too long, so let me chop some of this off. I'm just going to go straight 300. That'll put me in spec for the length. Our wing. You have two basic choices here for shape. Lines and B-spline. Now, lines are just straight lines with angles. B-spline, I can get curves out of my B-spline. So if you noticed, let me do that one more time real quick. When I have the lines and I haven't adjusted anything, my drag's right here. When I hit the B-spline, because it angles some things, or curves some things rather, look at this, my drag is sliding right on up. So that alone is very helpful. As I move things around, I want to see what happens with these little sliders. So if I pull this down longer, what happens? Well, let's see. Here we go. We got some moving in the right direction. Neutral point for pitch came down a bit. Horizontal stabilizer pitch came up. Center of gravity came up a bit. Roll moved somewhere. Still unstable in yaw. Now, it said in outputs, my wingspan is too long. Well, what I need to do is take this, and whatever I do on the left or the right, it mirrors across the y-axis here, so I don't have to do both sides. It copies these over, but you know, I'm going to come in, I'm going to start moving stuff around. I'm going to see what happens. Alright, so here goes the pitch for horizontal stabilizer. And what happens if I start playing around with these? Well, let's find out. Pull that down some. Pitch comes up a little, you know, and I'm going to try this in all different directions when I'm first getting started, but I'm just moving stuff so I can show you quickly. These ones, any of these round ones, control more about, it's not moving the actual points in here, it's moving the outer shape of the wing. Pulling that out brought my center of gravity pitch up. You know, if I go and play around with these, what happens? Let's see what that does. Doesn't look like it did a whole lot. So I could either leave it, I could undo it. It's whatever. My options here, just to show you, I can do how well sanded it is, and just for the heck of it, let's try heavy, see what happens. So the neutral point's coming down, the pitch center of gravity is coming down, but the weight's going up. Now, again, I gotta have so much weight, and I can deal with that. And these going to the right is best. Down here is okay, and middle better, and unstable. I want these going up. What happens, you know, and just playing with things. What happens if I pull this out? I don't know. Let's see. You know, do these go up or down? If it goes up, I keep it. If it goes down, I move it back. You got some different choices for your type of angle on the wings. You can change the angle on your wings. Let's try 15 and see what happens. Oh, here goes my roll, headed in the right direction. So, you know, I'm going to keep that. I could try 16, I could try 17, I could try 14, 13, I could try whatever and see what happens and adjust accordingly. Just because I can, I can change the color of stuff, give myself a blue wing. Why not? The horizontal stabilizer, it's going to be the same deal here. I can control the shape. I can shape it. I can control the type of shape. That's going down. Maybe I don't want that. How well sanded it is. Again, just I'm watching these to see what happens when I make these changes. The least important of them, but just kind of fun, I can color the thing, so when I race I know whose is whose. Um, what happens when I move some of these around. I'm getting trade-offs here, so I got better pitch, but the neutral point went down. Again, I can play with some of these different shapes and see what happens, if it gets better, if it gets worse. That's getting worse. Well, what will this do? A lot of that type thing. Well, that didn't work out so well, so maybe I pull this back in. That's going up. Well, I could try some more. So hopefully you kind of get the idea of what we're saying here. Sometimes you might get this error applying sketch. Usually I don't worry about that unless it really locks up on me, seizes up. I'm going to go ahead, just for the heck of it, see what happens. Pull this out wider. Gets better here, gets worse there. So again, maybe I want that, maybe I don't. I'm going to go ahead to done. I'm going to jump down to my vertical stabilizer. Now with my vertical stabilizer, we have just two options, the color, and I have the sanding on it, and I'm just trying heavy on all these because I can. Maybe I don't remember what I want this to be. If I want it big, small, whatever, I can always go back to research. I can go into I could go through a bunch of these different things, but let's see if I go in and look at pitch. Well, what do I want here? Slide these things around. I can see how things are going to change. All sorts of information that can be beneficial to me. That static margin will be pretty big when it comes to how well this thing's flying. Yaw, optimization, you name it. So good rule of thumb is design a fin with a surface area that's about 1/3 to 1/2 the surface area of the horizontal stabilizer. Well, that was going to help me with this. I want this to be about 1/2 to 1/3 of the size of this, area-wise. Well, I need it bigger. Let's pull this up, see what happens. Here comes my yaw on up. What happens if I move this up? Here comes my yaw some more. If I make this shorter, if I make it wider. So all these things I can play around with and see what happens. There, it's headed up. If I pull this down some, does it get better or worse? It's getting worse. Let me pull it up higher. It's getting a little better. Now, again, I can go back to research and look at all these things. One thing just to show you real quick, and then I'll call it quits real soon here. Pitch, center of gravity. Well, center of gravity is going to be way up front, and I can tell just because the wings hold more mass than anything else on here. One thing I can do here is in the wing, the X offset is the distance from the front of the glider to the front of the wings. I want to make that bigger. I'm just again an arbitrary number, which means kind of a randomly picked number, not for any reason. I went 90. Well, here we go. That's shooting on up. So that's a good thing. I'm all in the green, nothing's in the red. Well, let's see what happens. When I start getting a halfway decent plane, or what I think is going to be decent, I'm going to go to File. Again, this is not Google. Do not close this program without saving, or you're going to be in some bad shape. I'll save it. I'm going to make myself some, notes. At this point, I'm not going to list out everything because I'm recording this, but how about initial design, partially optimized. I'm not completely optimized because I still have stuff down here towards the middle and the bottom side. I want to test this thing, so I'm going to do save and enter competition. And I'm going to go to competition. And what you're going to find here is your plane will be understaged. There might be other ones here depending on who just saved. I'm going to go ahead, I'm going to put mine in as a contender. Don't bother with the out of spec planes. On that note, before I even do this, I should have, here's what I should do. I should go to outputs, design specifications. I want to make sure I'm all in the black. If I'm in the red, I don't want to race yet or fly yet, compete. I want to go back and fix anything in the red. I'm good. I'm going to go to competition. I put mine here in contender 1. I'm going to get someone for contender 2. Well, I got my other gliders and I got Carson. So Carson, here we go. And we're going to start. Now what we're looking for is we want it to hang in the air for as long as possible. Now that one, Carson's working on his, but it went up and came down pretty quickly. Mine's not doing horribly. I can definitely make it better. Okay. I could go in and look at the numbers and kind of compare and see, alright, well this one's lighter, you know, and just based on if someone crushes me, I'm going to go in and see, well, how is theirs different? And what can I do to make those things better? Well, maybe, you know, the static margin is negative. Well, I don't remember how to do that. I go back to research, I find out, and then I go do it. Here, for one thing, if you don't want to wait, if they start taking a long time to fly, once you start running one, and let me take one of mine, old ones, and this one, and I'm going to go ahead and start it to show you this. Click competition. There's my results. So if I click competition, it immediately gives me my results. And here it is. That one runs 8.61 seconds. And, you know, so I definitely have some work to do on the one we just set up. I would go back to engineering. This is what iteration is. I come back in, and I know I need to do something with this horizontal stabilizer. Well, let's go in. Let's try changing the shape around. I'm going to go back to lines just because. I'm going to see what happens. Already, look at that. It's going up. It's a good thing. I want to play around with the size and shape and stuff, but already that's better. Well, I made an adjustment. I'm going to go in. I'm going to save again. Adjusted the horizontal stabilizer. Normally I add in that what it did and stuff, but I'll save it in our competition, and I'm going to go back and run and see how it goes this time, and that is an iteration, and when I do it again, that's another iteration, and it's just a loop until we either run out of time or, you know, in real life if we ran out of money, that kind of stuff. But the beauty of this program is it's just time's the only thing we're really going to run out of. Put mine in here, take Carson's again, we'll run it. I'm impatient and I don't want to waste your time, so I'll click competition. I'm up to 6.2 seconds, so I've almost doubled my time from the last time. I'd come in here again, and I just keep doing the same thing. Well, this is still pretty low, this is still pretty low. I'm going to go play around with both stabilizers and try and adjust this and get this better. And I'm going to save it and run it, and then I'm just going to repeat that over and over. So hopefully this helps you out and is beneficial and how this all works. One last thing, when you come in after you've been working and you come back in, don't forget to open your design. People tend to freak out and because it's back to the just generic original design. Well, you got to open your design. And when you go in, if I really butchered let's say I really messed the thing up. I went in, I made changes, and it was terrible. I can go back to my previous revisions and start from, maybe this one was a good one, and this one was bombed. I'll open this and start there again, and it'll replace, revision 4 will be starting from 2. I can also go in my journal, and I can look at my grades and stuff. I can see if I've done everything. I can go in and see all of my gliders here that I've made, and you can see I've made quite a few. But if I went into just one section or if I went into just one glider. See, glider for videos, the one I was just working on. Well, first time I ran it was here. Then revision 2, revision 3. And again, we're going for length here, so 62019. So just so you know, you can go in, you can see a lot of information. I can see everything about what I changed. I can see my notes I left myself, which can be really helpful. I can see all the numbers here. I go into this one, well, same deal. So again, I hope this helps. Always ask questions when you need some help. There's the help section. There's the research section. You have all sorts of resources available to you. Remember, technology is all about using those resources wisely. So, best of luck. Let us know if you need help. Bye, guys.